An element that's in your toothpaste is at the heart of a cosmic mystery. I'm Sanjana Curtis, and this is Stardust, a series where you and I will do a deep dive into the elements of the periodic table, where in the universe these elements were created, and their role in our lives here on Earth. Today I have for you a story of beauty, danger, and mayhem, the story of fluorine. With 9 protons in its atomic nucleus, fluorine is the lightest halogen, an element that combines with metals to make salts. It is also the most reactive non-metal. Fluorine will combine with basically anything, even famously non-reactive elements like the noble gases. So for example, fluorine will combine with xenon. Fluorine has only one stable isotope, fluorine-19, and as a gas or as a liquid, fluorine is a pale yellow in color. Fluorine is found in a mineral called fluorspar, or fluorite, which is a compound of fluorine with calcium. It is cherished by many for its beautiful colors. Fluorite also has an unusual property, where it glows under ultraviolet light. The word fluorescent itself was coined due to this effect, but fluorite can glow in many different ways. It can be thermoluminescent, it can even be triboluminescent, meaning it glows when crushed. The discovery of the elements over the course of human history was risky business, and fluorine is a great example of this. Fluorine was proposed as a new element around 1813, but it wasn't actually isolated in its pure elemental form until 1886. Around 1813, chemists had realized that the acid produced when you heat fluorite must contain a new element. Unfortunately, that acid was hydrogen fluoride, or hydrofluoric acid, an acid so powerful that it can be used to etch glass. I'm not kidding, here's some glasses etched using HF. So hydrofluoric acid was very difficult to work with, let alone extract pure elemental fluorine gas from. And if hydrofluoric acid itself wasn't bad enough, pure fluorine gas is also highly irritating and toxic. It can do damage to your eyes, lungs, and skin. Even famous chemists like Sir Humphrey Davy suffered greatly from inhaling hydrofluoric acid. Some chemists even died in their pursuit to extract elemental fluorine. Finally, in 1886, Henry Moissan was able to extract fluorine, and for this he won the Nobel Prize in Chemistry. So while fluorine in your toothpaste can reduce the risk of dental cavities, it is not an element to play with in any large quantities. So how did fluorine come to exist? This is actually not yet understood. Fluorine is made in stars in some fashion, but it is not as easily produced as its neighboring elements, so for example carbon, nitrogen, oxygen, or neon. It is somewhat rarer. It is also fragile, so it's used up very easily in stellar interiors to produce other elements like oxygen or neon. So the challenge with fluorine is not just producing it, but also getting it out of the star. There are about half a dozen different proposed ways of producing fluorine that I'm currently aware of, involving different types of stars, different phases in the lives of these stars, and stellar explosions. But I will tell you just the 3 main ideas. Number 1. Fluorine could be produced through a particular reaction sequence in stars between 2 to 4 times the mass of our Sun, while they are undergoing a particular phase in their evolution, while they're on something called the asymptotic giant branch of their evolution. The reason these stars may be able to get fluorine into the universe is because they are very convective, and so stuff that is deep in the interior of the star, maybe fluorine, can get dredged up to the cooler stellar surface. And so in this way, fluorine may be able to escape getting burnt to other elements. This scenario has some support from observations as well, although it is very difficult to measure fluorine spectroscopically. Option 2. Fluorine could be produced during helium burning in a particular class of stars called the Wolf-Rayet stars. These stars are hot and luminous and 20 times the mass of our Sun or more. They also have very strong winds, and so the winds can help fluorine escape without getting destroyed. And finally, option 3, when massive stars die at the end of their lives in a core collapse supernova, fluorine could be produced through something called the neutrino process. Neutrinos are massless particles zipping through space, minding their business, rarely interacting with matter. But in a core collapse supernova, a lot of neutrinos are produced, so it is possible that as these neutrinos are leaving the star, they interact with the neon in the outer layers of the star, knocking out a neutron or a proton, and ultimately producing fluorine. Which exact scenario or combination of scenarios produce the fluorine in the universe and hence the fluorine in your toothpaste remains to be seen.